In this video, we're going to look at how we do transformations on graphs. So that's moving things up and down, stretching, squashing, flipping, those sort of things. Okay, so here what I've tried to do is summarize, if you like, the rules, because we don't really do it by redrawing the graphs each time, because often you don't actually have the information to do that with anyway. So we do it by basing it on understanding what happens generally every time. Now there is a nice divide between the two types here. We've got ones that relate to changes that happen outside the bracket and ones that happen inside the bracket. So anything outside the bracket is generally actually an easier change, and it's a change vertically. Whereas those changes that happen inside a bracket require a little bit more thought, and they happen in the horizontal direction. So let's just go through the three different types for each one. So here we've got f of x, which just stands for a function of x. So that just means it could be the function of x could be x squared minus 2, for example. It could be x cubed plus 4x minus 7. It just stands in for whatever that equation is, if you like, of the line or the curve that they've drawn on the graph. Okay, so here this is what I mean by outside the bracket. So here are the brackets, and we're adding something on to the whole function, so outside of the bracket. So this means that it will move up or down. If it's positive, it will move up. The whole graph, just pick it up and move it up by however many it says here. If it's a minus, then you move it straight down. Doesn't change in this direction, no other changes. You simply pick it up and move it up and down. So it's a bit like a very simple translation, shall we say. Then the next thing that we might have is this situation. So what we've got here is that we've got a number multiplying our function. Again, it's outside of the brackets. Now, when we've got the multiplying outside, this affects the graph by either stretching it or squashing it. And that does it in the vertical direction. So if you imagine you've got a curve like this, if it stretches it, it's going to take the point of the curve further up, but the actual width of the base of it is not going to change at all. If it squashes it, it's going to bring that down and flatten it. Okay, so it will stretch it when this is a number bigger than 1, and it will squish it when this is a number that is smaller than 1, so a fraction. And finally, we have this situation where we've got a minus, so we're a negative version of our function. So this is still a movement that's going to happen in the vertical direction. So it's literally going to flip the graph in this way. So what was on the bottom will become the top, and what was on the top will become the bottom. Another way of thinking of this is to think of this, it's a reflection, that's what we're talking about, where the line that we're reflecting it in is the x-axis, which is that one that goes there. So we're flipping the graph over. If we're dealing with ones where it's inside the bracket, so if we look here, we've got f of brackets x plus a. So the plus a is now inside the brackets with the x. So this means a movement in the horizontal direction, but it moves the opposite way to what you would think. So if it's a plus a, it actually moves backwards, and if it's a negative, this a, then it moves forward. So it's contrary. So all these ones that are inside the bracket do the opposite, if you like, of what you might expect. But it's just a simple pick up the graph, move it this way or that way. Nothing else changes. So here we have f of brackets ax. So again, we've got the a multiplying the x inside the bracket. So this is also going to stretch and squish, but this time it's going to stretch or squish it in this direction. And just like we've just been mentioning, it's going to do the opposite of what you think. So it will stretch it when your a is less than 1. So for example, if we had a half x in there, it would make everything twice as wide as it was before. It doesn't affect the height of the graph, it's only going to affect how wide the graph is. Conversely, if a is a whole number bigger than 1, so if that was 2a, it's actually going to squish everything. So it means that the graph is going to come in and be half the width, half the size this way that it was before. Okay, and then finally, to complete this, we've got f of brackets minus x. So the minus is inside the brackets here. So this is going to be a horizontal movement this time. So it's going to be a reflection of the graph, but it's going to turn it this way. So your mirror line this time is the y-axis, and it's going to flip. So what was on this side will now be on that side, and what was on that side will now be on this side. So I'm going to have a look at some examples now. Hopefully that will start to make a bit more sense. So I'm hoping you're going to be able to see this well enough. Right, so typically they give you a graph where they've already drawn a curve, and so this is our f of x line here. Okay, don't worry too much about the coordinates and that aspect. I'm not going to deal with that aspect of the question here. We're just going to show and try and demonstrate where these graphs would move to. So the first one we've got here that it wants us to transform into says y equals f of x minus 4. Okay, so this is outside the brackets, and it's a takeaway. So that means it's simply going to move it vertically. It's going to move it down 4 here. Okay, so at the moment, so these points are somewhat helpful in working out where to put it, but it's only meant to be a sketch here. It's not supposed to be an exact drawing. Okay, so at the moment in the y direction it's 2. So if it goes down by 4, it's going to end up with the bottom of the curve is going to be here at minus 2. So it's basically going to be exactly the same shape. Sorry, I'm not very good at drawing it, but we've just moved it down. The whole graph has moved down 4 points. The next one that they're asking us about here is y equals 2 f of x. So again, this is outside the bracket, so that means it's going to change in the vertical direction. But what this means is that this is going to stretch by a factor of 2. Okay, so all of your points, if you like, are going to be double what they were before. So it does have a bit of movement to it as well. Okay, so this is where the point would be here for f of x, our normal graph here. So again, we've got a vertical movement, so actually it's going to go up a bit, but it's also going to be much steeper. So these points here, instead of being sort of this distance away, it's going to be twice as far. So it's a bit challenging to draw on here. So that point, let's take a point a bit further down. So this point, which is here on the original one, in a sense will still be there in terms of the x direction, but obviously it's going to be twice as high up this time, and the same sort of thing would happen on that side. So you can start to see what we mean by stretching it here. So if I draw in, again, that's not the best, it should be a bit more curved there. So we've gone from this nice fatter curve to one that's been stretched out in this way, so it's actually a bit narrower inside. So that's your y equals 2 f of x. So then finally they're asking us about y equals f of 2x. So now we're inside the bracket, so it's going to change it horizontally. So what that means it's going to do is, because that's a whole number, it's actually going to squish it horizontally. So I'm going to have a bit of a challenge drawing this on top of this. So I'll try and draw it on top, but then I'll try and draw it to the side as well afterwards, okay? Or I know what we'll do. Let's pretend we're recreating. So I know this isn't going to be perfect, but this is our original curve. So this is going to come in by a factor of 2 this way. Okay, so this is going to stay put here. So this point here is going to be half as far in. If you think about a middle line going through there, that one is going to come in and be half closer, and the same is going to happen on this side as well. Okay, so we're going to squish this curve in like so. Okay, so it does look quite similar to the stretched out one we had here, and that's partly, I think, because we've got quite a simple curve. But the idea is that this one is stretched out because it's moved up. This one is stretched out, if you like, because it's a factor of 2 and we've squished it in. If it had been a half here, then the graph would have come out further, so it would have come out by a factor of 2, if you like, and it would have been a much fatter curve in that direction. Okay, so we've seen 3 out of the 4 transformations that I've just been talking about. So I'm just going to try and demonstrate the 4th one. Okay, I know we've also got the negative ones that we haven't seen yet. We'll come to those in a minute. So here is our y equals fx graph, and they want us to show y equals f of x minus 1. So it's inside the bracket, so that means it's a movement in the horizontal direction. It's only a stretch when we multiply, so this is a movement. Now it says minus 1, so we do the opposite. We're going to pick this curve up and move it forward 1. So this point here, which is at 2 now, is going to be at 3. And this one that's 0, it's going to be at 1. So this point down here will be here. And then if I pick a couple more, I'm going to pick these ones because they're fairly easy. So that's 3, so that's going to move there, and that's going to move there. So you should just about, if you want to, you can maybe do the top ones as well. So that would be there and roughly there. Okay, so now you can just sketch that curve in. So you can see it's simply picked up that curve and shifted it over by 1 in this direction. We'll try and look at a couple more examples here. I'm hoping you can see the lines that are already drawn on these. It's not too faint. So on the top here, we've got a y equals fx, so we've got a different looking curve this time, and they're asking us to sketch y equals f of x plus 2. So it's outside the bracket, so it's a vertical movement. So we're literally picking all of this graph up and shifting it up 2. So just pick the key points. So this one will go up 2, this one will go up 2, this one will go up 2, and this one will go up 2, like so, and then that's going to be there. So we're going to just sketch that in now. So you can see these are the easy ones. The stretching ones are a little bit more difficult. Okay. Now on the bottom we've got the same curve, but this time they're asking us for y equals minus f of x. So it's outside the brackets. So that means we've got vertical movement. What it means is that this is our mirror line. So we're literally going to flip it this way. So what's on this bottom at the moment is becoming on the top. So it's going to kind of do that. And this point is now going to be down here. That one's not going to move. And this one will be down here. So to continue that, I'm going to have it kind of like that. Okay, so I'll try and just dot in just so it's a bit more clear. So this is where the original was, and we flipped it over, so it's now the other way up. So a couple more examples. Here's our curve. So we've got a nice upside down quadratic curve here, and they want us to do y equals f of x minus 4. So it's outside the brackets, so that means it's a vertical movement, but this time we're going to shift everything down 4. So this one's at 4, so it will go down to here, and then just here's going to go down from 0 to minus 4, and the same here. And then if we do the bottom ones, they're also going to go down 4, so they're going to go to there and there. So our new curve, it's going to kind of fit inside the old one like that. So the original one is up here. Here's the new one, which we've just shifted down by 4. Got the same graph here, but here they want us to do y equals f of a half x. And that's inside the bracket, so that means we're horizontal now. And because it's a half, it actually means things are going to double in this direction. Okay, so this point here is now going to be twice as far out. Same on the other side. Here, the same is true, so that's going to go to there, and this one's going to go out to here. This one will stay exactly where it is. So we're going to draw that in like this, so you can see we've got a much fatter curve now. So here's the original, here's the changed one. Just 2 more examples then. So we've got some quadratic curves again here. On the top one, they want us to do y equals f of x minus 3. Okay, so it's inside the brackets, so that means it's a horizontal movement, and it's contrary to what we think. It's not going to go back 3, but it's going to go forward 3. So this point here is going to move forward to here. This one's going to go here. This one's going to go here, and let's do some more of these. So that's going to go forward 3. That's going to go forward 3. Let's roughly do those as well. So that's 1, 2, 3 there, and we draw in our new curve. So we've got our original curve here, and we've moved it forward 3 in this direction. So the final one we've got here is y equals 2 f of x. So it's outside the brackets, so that means it's a vertical change. So in effect, it means everything's doubling. Yeah, that's another way to sort of think of it. But it's going to be stretched in this direction. So we're thinking about all the doubles, doubling everything. So this point here at the moment in terms of y is minus 1, so it's going to become minus 2 if we double it. The 0, if you double it, is going to stay 0, of course. This is part of the stretching. Here we've got y equals 3, so that's going to become y equals 6 up here. So our new graph is going to look like this. Okay, so our original one does this, and this one's been stretched up in this direction. So you can see when we do these ones, we have some movement of the graph up or down as well.